Good afternoon, guys. Guys, see the screen and email. All right, guys. Do this paper and you grade yourself. And the pass mark, as you know, 65%. You see? And the aim always is to learn from the mistakes. Redo any question you got wrong, and any question you did not do. That is the aim. All right? So let's go. I want to just work from number one. All right? It's going to work from the front. Work our way back. And it's being recorded, so I can move relatively quickly. Hello, mommy, okay? All right? All right, good. All right, so the first question is for us to find the exact value of this. And we can use our calculator. It's like your 3 marks question on an exam paper. So you just have to type that in the calculator exactly as it appears there. So it's 5/6. What did I do? 5/6 plus 2/3. I put minus. So you have to be careful. I have minus. It's a plus. And then minus now. That a fraction of 12/35. And that fraction is being multiplied by 7/9. Now, if you're working this out step by step, you have to work out this first, the multiplication first, right? You have to follow, but the bomb dash, some people say P that bomb dash, different people call it different things, but you have to follow the proper order operation, which you have to work out the multiplication first before you add and subtract. But anyway, this is telling us that that answer is 1.23. The 3 repeated, but you have to give the exact value, in that you cannot give that 1.233, give it as a fraction. Just make sure you type it in correctly. 5/6 plus 2/3 minus 12/35 times 7/9. And that is equal to 37/30. All right, that is it. Next question. Calculate that again, give the answer to 3 decimal places. Again, I'm going to put this in the calculator. Make sure the calculator is in degrees. If you look up at the top of this calculator, you see the DEG up here, means that it is in degrees. Some calculator will have a D on it like that for degrees. Make sure the calculator is in degrees once you're gonna do any trigonometry work. So this becomes this is the square root of 1 minus bracket. That's a cosine of 37 degrees. And then that is being squared. So that square right up here is being squared. So I have to square that as well. So you square that. And I'm getting 0.601815 and so on, right? But the question said we must give it to 3 decimal places. So these are the 3 decimal places right here. 1, 2, 3. I'm going to use this 8 to correct that 3 decimal places. The 8 will increase it by 1. And so it becomes 0. It increased this digit by 1. So it becomes 0.602 to 2 decimal places. That is the answer. All right. Just making sure that we type the thing in the calculator right, which we did. Next question. We have to write this in standard form. Now, some calculator can do it for you. Put it in there and change it to standard form. Some calculator can do it. But in standard form, we need the decimal point in front of the first non-zero digit. So we need decimal point right here. Right? Now, this is a very small number. See, it's 0.00 something. So when it's a very small number, the times 10, the power of the 10 is a negative. So you can know that, right? Because it's a very small number. So to convert this and move the decimal point to here, let's do through the operation. It will be 0.00527. To get the decimal point 3 places to the right to put it where we want it, we would multiply by 10 cubed. Cancel out this multiplication by 10 cubed. We also multiply by 10 to the minus 3. So what I've placed in the bracket is what's going to move the decimal point for you. So multiply by 10 cubed and then multiply by 10 to the minus 3. It's like it cancel out back the multiplication by 10 to the minus 3. But this is what will move the decimal point and put it where you want it to be. So the end result is that 5.27 times this now, times 10 to the minus 3. And that is the answer. All right, nice and easy, just like that. All right, let's continue. Next question says, Aresh worked at a call center for 35 hours each week. So that's 35 hours per week. He says he is paid an hourly rate of $11.20. That's $11.20 per hour. Calculate the amount of money Arash earns in a 4-week month. 4 weeks month. 4 weeks. So it's 4 times the weekly amount. So we might need the weekly amount. So let's work out what the weekly amount is and then multiply by 4. All right. So all right. So the total earned is going to be 4 times the weekly amount, 4 times the weekly pay. And the weekly pay is 35 times the hourly rate. So it's 4 times 35 times 11.20. Now you can actually calculate all of this one time, you know, but I want to see what the hourly amount is, the weekly amount is. So I'm going to put in that line of calculation and work this out so we can see what that figure is in case we need to use it. Yeah? Huh? So what? No, call them. They're supposed to know class start already. They don't want to come, let them stay. 35 times $11.20. So that's $292 per week in case we need the figure. And then the final figure now is 4 times that. So the multiply this now by 4. And it is $1,568 is the amount in 4 weeks. That is the answer. 4 weeks payment. All right. This one says now, in a certain week, Arash work 8 hours overtime. 8 hours of overtime. Overtime is paid at 1.5 times the usual rate of 11.20. So the overtime rate is 1.5 times this. Can't work it out here in case we need it. The OT rate. OT means overtime. The OT rate is equal to 1.5 times $11.20. I'm just working it out here, which becomes equal to, me shift this up a little bit. Just working it out here so we can have it, what the overtime rate is. Let's work that out quickly so we can have the actual figure. So it's 1.5, which is the same as 1.5 times $11.20. That's $16.80. You put it, even though you get 16.8 because it's money, you put 16.80. Money must always have two decimal places, right? So that is $16.80 is the overtime rate per hour. Overtime hourly rate is this. It says find the total amount of money Irish is paid for that week. So the total amount is paid for that week is a weekly amount plus the overtime amount. Right? Remember, that's how we need this weekly amount of $390. So the total for that week, it's gonna be the regular pay plus the overtime. OT means overtime pay. The regular pay we worked up here already. It is $390. That's why it was important to write that out. $390. Plus the overtime pay now is 8 hours times its overtime rate. 8 hours times that overtime rate. So it's 8 times $16.80. And we can put everything in the calculator and just get one answer for this one. I don't need the actual overtime pay. I just add up everything. So it's $390 plus 8 times 16.8. That's $524.40. $524.4 means 40 cents. That is it. That question is done. Very good?
Yes, sir.
All right, good. Let's continue. This question wants us to simplify this. So the multiplication of fractions, we just need to simplify, cancel down the values that have common factors. So let's go. So this x cancels with this x. When the pen thinner, so you can see better. Right. So this x cancels that x, so the x's are gone. And then this 4 into this goes 1 time, 4 into 16 goes 4 times. Then 5 into this goes 1 time, and 5 into 15 goes 3 times. So what we have left here is 1 times 3 on the numerator, which is 3 over 1 times 4 on the denominator, which is 4. So the answer is just 3 over 4. 3 over 4, you cancel it down. 3 over 4. That's it. It's simple, quick and fast. Very good? Nice and easy. Next one. Solve this inequality. So to solve this inequality means that you need to express it with the m. M is the unknown. Make m the subject of the inequality. The key thing to remember about the inequality is that when you multiply or divide with a negative number, you have to revert the inequality sign. What we're going to do, we're going to try to get the m on the left side. We're going to group the m on the left side. All right? So you solve this in the same steps as you would solve 12 minus 4m equals 5 minus 8m in same steps. Trying to make the m subject. The only difference is that with the inequality, if there comes a point where you have to multiply or divide the negative number, you have to remember to reverse the inequality sign. All right? So for this one, I'm going to group the m on the left side. I'm going to take this negative 8m and bring it over here. It becomes a positive 8m. This minus 4m is already on this side. Make the pen thicker again. Right. So I'll say, take this 8m, bring it over here. It becomes positive 8m. Minus 4m is already there, so you still have minus 4m. The sign stays less than because I did not multiply or divide. Less than or equal to. 5 is on the right side. That stays as a 5. This 12 goes over and becomes a negative 12. Negative 12. Then 8m minus 4m is 4m. Less than or equal to 5 minus 12 is negative 7. They will divide by 4. That's a positive 4. So there's no need to reverse inequality sign. So the m is just less than or equal to negative 7 over 4. Let's do it another way. We'll put the m on the right side. That's what the difference is. Let's do it this way. So we could say, or we could choose to put the m over on the right side. So let's say we're transposing the m on the right side. So I'm going to leave this 12 where it is, 12. Take this 5 and bring it over this side, become minus 5. The sign stays less than because I did not multiply or divide with a negative number. The 4m goes over here, becomes a positive 4m. And this minus 8m is over here still. So it stays over there. That's minus 8m. Then the 12 minus 5 is 7, less than or equal to 4m minus 8m is negative 8m. Negative 4m, sorry. Then to get rid of this negative 4, you have to divide by. So you want to divide 2 by negative 4. Thing with this one now, you have to reverse the inequality sign by dividing with a negative number. So see here, divide by negative 4. We have to reverse the less than or equal to sign. When we divided by 4 over here, there was no need to reverse the sign because that was a positive 4. Okay, we divide with a negative 4 now, you have to reverse the sign. And so this becomes negative 7 over 4. Less than, no, it becomes a greater than. The sign becomes a greater than. Greater than or equal to m. And this inequality can be spun around and read the other way. If you read it from right to left, it is saying m is less than negative 7 over 4, which is the same answer as this. So if you turn it around, it would be m is less than or equal to negative 7 over 4, which is the same answer that we have over there. All right, just remember, if you do it in a way where there comes a point in an inequality, we have to multiply or divide with a negative number, you have to remember to reverse that inequality sign. You absolutely have to remember that. All right, next question. So next question, we were given this compound shape, which is like a L. It said diagram below shows a compound shape LMNPQR made from 2 rectangles. So there are 2 rectangles here. It says the length in the diagram, the lengths in the diagram, which are written in terms of x, are in centimeters. So these are the lengths that are written in terms of x, they are in centimeters. But there are a couple of sides that are not shown. So this side is not shown. That side is not shown. All right, we have to figure out what those sides are. It says, find an expression for the length PQ. That's this length. So PQ is basically going to be the, for everything up here, which is 3x minus x plus 3. That's what PQ is going to be. But I can appreciate that. It's going to be the full length across here, which is 3x minus the x plus 3. That's what it's going to be. All right. So it's going to be simply equal to 3x, which is the full length across here, so minus a piece here, which is the same as this, x plus 3. So it's 3x minus, put x plus 3 in a bracket, and subtracting the whole thing. They don't mess up the negative sign. So it becomes 3x minus x is 2x. And then minus 3 is minus 3. So it's 2x minus 3 that left becomes. So this piece is actually 2x minus 3. A lot of people put 2x plus 3 because they don't apply the negative on this plus. Turn it into a negative. All right, let's put on the diagram. So this length is 2x minus 3. 2x minus 3. Then I want RQ, which is this length up here, RQ. And a similar kind of calculation. The full length across here would be 4x minus 5. And this piece right here is the same as this, x plus 1. So it becomes 4x minus 5 minus x plus 1. Right? That's what this piece here becomes. This piece here becomes 4x minus 5 minus this x plus 1. Hope everybody can see that. All right, so it becomes equal to 4x minus 5. And to make sure you don't mess up the signs, you put minus and put this length in a bracket as well, which is x plus 1. So then it is 4x minus x, which is 3x. Then minus 5 minus 1 becomes negative 6. Minus 5 minus 1 becomes negative 6. That is that length, 3x minus 6. So this length is 3x minus 6. So those are all the lengths now, right? What else I wanted to do? It said given that the total area of the shape is 414 centimeters squared, show that this is true. All right. So what we can do is take the shape and to calculate the total area is either going to divide it this way and use one rectangle and a second rectangle, or you can decide to divide it this way and use one rectangle and a second rectangle. Your choice. The result's going to be the same. All right. You have to break it up so you can work it out that way. Let's say I'm going to do it this way. Let's say I'm going to break it right here and find area 1 plus area 2. So dimensions on area 1 is this length times this width. And dimensions on area 2 is this length, this length, these two. All right? Those will be it. So let me draw this a little bit better. All right, I'm gonna copy this down. All right, let's work it out right here. So I say the total area is 414, right? So we're gonna say area 1 plus area 2 equals 414. Now area 1 is this length times this width. All right, so that becomes 4x minus 5 times x plus 3 plus, and area 2 now is this length times this width, which is now 3x times x plus 1. This is area 2, that's area 1, and it all equal to 414. That's basically the equation. However, you know, simplify this equation down, I must get this one done. All right, simplify that equation. So let's go on. So it's gonna be expand out this and expand out that. So to expand this, zoom upon it, you multiply this times this first, you're gonna get 4x squared. And the middle term, remember, is a far product and the near product. So the far product and the near product. The far product is 12x. That's 4x times 3 is 12x. The near product is negative 5 times x. That's a negative 5x. So 12x minus 5x gives you a middle term of 7x. So the middle term is 7x, it's plus 7x. Then the last term is the negative 5 times the 3. That's this times this. Negative 5 times 3 is negative 15. That's the first bracket. Plus, I'm going to distribute this 3x now over these two terms. So 3x times x is 3x squared. And 3x times 1 is just 3x. And then what I can do, because this have a 0 up here, so I can take this 414, bring it over here, and make it negative. I'm going to put minus 414. That's all equal to 0. All right? Huh? This one? 3x times 1 is 3x. Okay. All right, ready now. So we're going to do the like terms now. So it's 4x squared minus 3x squared right there. So it's just x squared. Then 7x and 3x is 10x. Something is wrong. But I'm not getting what they have. But I have my x squared already. Something is wrong somewhere. Hold on. Something is, oh, I used the wrong side here. Should have used it 3x plus 6 for area 1, not x plus 1, not x plus 3. It's this triangle we're doing. A. So my mistake. My mistake. Let me start over. Let me start this over. Let's go again. It's the wrong side than area 1. So if I zoom it up, area 1 is this triangle in here. Mark it out in the red. Area 1 is this triangle. This rectangle, sorry. And area 2, I mark this one out in purple. It's this one over here. All right? That's what it is. So I use the wrong thing. So area 1 is really this length times this length. So you see, you have to be careful. And area 2 now is this length times this length, which is correct. All right, so let's go again. So area 1 is this length times this length, the red rectangle, which is 3x minus 6 times x plus 3. Plus area 2 now is this length times this length, the purple one, which is 3x times x plus 1. And that's all equal to 414. So that's what we're simplifying down now. All right? So let's go again. So 3x times x is 3x squared. And again, the middle term is the far product and the near product. The far product is 9x, that's 3x times 3. The near product is negative 6 times x is negative 6x. So we're talking about you come in here and say a quiet place. Negative 6x. So 3x minus 6x, no, sorry, 9x minus 6x is 3x. So it becomes 3x. Then negative 6 times 3 is negative 18. So we're expanding this bracket now. So this 3x times x is plus 3x squared. And 3x times 1 is 3x. That's all equal to 414. Simplify. 3x and 3x, 3x squared and 3x squared is 6x squared. 3x and 3x is 6x. And then I could have brought this over from the get-go. Let me rewrite this. I'm just bringing this over. So, huh? Huh? So let's bring this over one time and put that minus 414 equals 0. So now we're doing negative 18 and negative 414 is how much? Which is that? That's 432. So that becomes negative 432 equals 0. Then to simplify now, we divide this 2 by 6. So divide 2 by 6. Divide 2 by 6. This becomes x squared. This becomes x. And this becomes 432 divided by 6. It becomes 72. 72. And that's all equal to 0. Which is what they told us to show. That is it. All right. So show. So can maybe take this and shift it up a bit. Shift this down. Over this diagram here. So see two rectangles separate. That's it. That question is done. Number 3. So mark as you go. Number 3 says the diagram below shows a semicircle with a diameter AC. And it says these are points on a circumference. And AB is equal to BC equal to 8.2. So this length and this length is the same. Now that's a semicircle and that's a diameter. And by diameter subtends an angle of 90 degrees. So you should know that this angle here is 90 degrees. So that's actually a right angle triangle. So put in what we know. This angle becomes 90 degrees because the angle subtended by a diameter is 90 degrees. You see the half of a circle and that's a diameter. Angle subtended by a diameter is 90 degrees. And because this is isosceles with this length also equal 8.2, then these two angles equal, each of them equal 45 degrees. Because total angle in the triangle is 180, so each of them is 45 degrees. So this is 45 degrees, and this is also 45 degrees. Might not need it, because it's a right angle triangle. We can use Pythagoras theorem or so-called thought in it, right? It says, say the geometric name for the line AB. What's this line called? AB is a chord. Line connecting 2 points on a circumference is a chord. So you see the axis in CSEC as well. Next part. Find the value of the radius. So to find the value of the radius, we can find the diameter across here, so, and then divide it by 2. We could also maybe drop, because that's an isosceles triangle, you can drop this line down here, perpendicular bisect of the base. Working this triangle, we find this length, that's a radius, and this is also a radius. So we could set up an equation with the radius here, so. And then this will be an hypotenuse. This will be an hypotenuse. So you know the hypotenuse. So you would have r squared plus r squared equals 8.2 squared. And then solve for r. All right. So whichever way you prefer. I think most persons would maybe find the diameter and then divide it by 2. All right. But I'm going to use the r squared method. So let me drop this down here. Drop this across here. Keep a 90 degree here. This is r and this is r. And I'm working in that triangle. So r squared plus r squared equals 8.2 squared using Pythagoras theorem, this triangle. All right. So if we do another way and get the same answer, no problem. So I'm going to write r squared plus r squared equals 8.2 squared, Pythagoras theorem. That is 2r squared equals 8.2 squared. That is r squared equals 8.2 squared divided by 2. And then square root now. So r equals the square root of 8.2 squared divided by 2. Write that out and you have your radius. All right. Write that out and you have the radius. So it becomes the square root of a fraction 8.2 squared divided by 2. And it is 5.5.5.80. 3 significant figures, centimeters. To do the other way, let's do it the other way and show it as well. More maths equals better maths. So we could find the diameter first. So we can say, or we'll find the diameter instead. And say the diameter AC squared is equal to, it's a right angle triangle, so it's equal to this side squared plus that side squared. which is 8.2 squared plus 8.2 squared. So AC then will be the square root of 8.2 squared plus 8.2 squared. So AC will be equal to whatever that is. So it will be the square root of 8.2 squared plus 8.2 squared, which would be 11.596. And then now the radius would be half of the diameter, which would be half of the 11.596. And if you write that out, you're going to get the same answer. Divided by 2. 0.5 times that to get the same thing. 5.8. So we're going to find the diameter first and then divide by 2. All right? So whichever method you use, that's all right. All right? Next part. It says each interior angle of a polygon is 160 degrees. Calculate the number of sides. We can do this two ways. If you know the exterior angle, then you also know the exterior angle. Remember, total exterior angle is always 360. Total interior angle is n minus 2 triangles. So we can work either way. Total exterior angle of any polygon is 360 degrees. We have said that multiple times. And if an interior angle is 160, then the exterior angle, not 40, be 20, because the sum of the exterior and the interior angle must be 180 degrees. So the interior angle is 160, then the exterior angle is 20. All right? So let's do it both ways. Let's do this two ways again. I use the interior angle method and the exterior angle method. All right, so using an interior angle method. Let's do it this way. Total interior angle. Total interior angle. Watch this now. Because it's a regular polygon, it means that all sides equal, all angles equal, right? That's what it means. All sides equal, all angles equal. That's what this means. Regular polygon means, this means all sides equal, all angles equal. So all angles are the same. So all, this means all sides equal. It also means all angles equal. All right? And the number of sides we're trying to find, we're going to call that n. Let's say it has n sides. Right? So if you're using total interior angles, it has n sides, it also therefore has n angles. And because all angles equal, all sides equal, all angles equal, if each interior angle is 160 degrees, then the total interior angle is 160 times n. Right? The total interior angle is 160 degrees times n, firstly. But that total interior angle is also equal to n minus 2 triangles. N minus 2 times 180 degrees. Remember that. Total interior angle equal this, but it also equal this. That's why it's one equation to find n. This is n minus 2 triangles. Remember, n minus 2 triangles. A polygon can be divided into n minus 2 triangles. Remember these things. N minus 2 times 180 degrees. So if you solve this, then you're going to get n. Right? Solve this equation, you're going to get n. So that's 160 degrees times n equals 180 degrees times n to expand the n times that. And then you minus 2 times 180 is 360 degrees. If you transpose this now, throw over the 360 over here, so you get positive 360 degrees. Equal, take the 160 over here and subtract it. You're going to get 180 degrees n minus 160 degrees. I just put 20 degrees, 20 degrees times n. 20 degrees times. But can you understand that? you take the 160 and bring it over and subtract it, you're gonna get 180 minus 160 to give you 20. And to get the n now, you divide by the 20. So the n equals 360 degrees over 20 degrees, which becomes 18. So there are 18 sides. That's using total interior angle to do it. Let's use another method of total exterior angle. Right? So we know that total interior angle is always equal to this, n minus 2 triangles. Now, if the exterior angle is 160, this is the key thing now. Exterior angle equals 160 degrees. Therefore, not the exterior, the interior angle is 160. The interior angle is 160. Therefore, the exterior angle is equal to 180 degrees minus 160 degrees, which is 20 degrees. So each exterior angle now is 20 degrees. When I use a method now, we say total exterior angle equals 360 degrees. That's all we know. Total exterior angle is always 360 degrees. And if there are n sides, then there are n angles. N sides, n angles. So we have to remember the number of sides and number of angles are the same. So n sides, n angles. That's what it has. If it has n sides, then it also has n angles. And each of those n exterior angles is 20 degrees. It means that the total exterior angle would be 20 degrees times n, or n times 20 degrees. N of them. You can set up that way. N times 20 degrees is a total exterior angle. It is equal to 360. You divide by the 20 again. So you get by the same equation, don't you, in the end. So you get n equals 360 degrees over 20 degrees, which means that n equals 18. That is the answer. So whichever method you use, that is it. So remember, if you're using total exterior angle, this total exterior angle is always 360. And total interior angle is always equal to this. And put it in a box. N minus 2 triangles. So if you're using an interior angle method, that's what you have to remember. Total interior angle is equal to n minus 2 triangles. So you can use it from the perspective of total interior angle or from total exterior. Remember, if the interior angle is 160, then the exterior angle is 180 minus 160. Okay, Stan? Very good. All right. Explain what? The second one is that the total exterior angle is 360. And if the interior angle is 160, if one interior angle is 160 degrees, then the exterior angle is 20 degrees. But the sum of the exterior and the interior must always add up to 180. Straight up, now that's a diagram, quick line. So if I show you one angle like this. Just using a triangle to help you, to show you. Right? Just using a triangle to show you exterior and interior. If this angle inside here, so if this angle inside here, so it's theta. That's an interior angle. Then the exterior angle is when you extend this side and form the angle out here. It becomes 180 degrees minus theta. Right? So the sum of the interior and exterior must all be 180. Right? So if you know the interior angle, you automatically know the exterior by knowing that the sum is always 180. So by them telling us that the interior angle is 160, and it says a regular polygon, so it means that all of the interior angles is 160. All the angles are the same because it's regular. When a polygon is regular, all sides equal, all angles equal. Right? So if the interior angle is 160 degrees, then the exterior angle is 20 degrees. And because it's regular, all the exterior angles are the same, 20 degrees. And the sum of them is always 360. But the sum of the exterior angle of any polygon, regardless of the number of sides, is 360 degrees. All right? The sum of the exterior angle of a convex polygon is 360 degrees. And that is it. All right. So this will be interior. This one will be interior. This one will be interior angle. And this will be the exterior. Corresponding exterior. They add up to 180 degrees. That's like total on a straight line. All right? Must always add up to 180 degrees. All right, let's continue. Next question. This question now is our transformation. Don't you need to calculate that now. So it gives us this shape. It's a quadrilateral. It's actually a trapezium. So the diagram shows a trapezium A drawn on square grid. Eh? What do I want us to do with it? It says on the diagram above, draw the image of A after it undergoes firstly a reflection in line x equals -1. See, I want to reflect in line x equals -1. Label it A prime. So we're going to reflect that shape in the line x equals -1. So we're going to draw the line x equals -1, which is a vertical line passing through -1 down here. So, right? And this is the line x equals -1. That's it. So this is the line x equals -1. I want to reflect in that line. So remember, do it one point at a time. Image distance equals object distance. So if we're doing this point first, it is 2 units to the line. It's going to go 2 units on the other side to here. Good? That's the first point. Then this point is 3 units to the line, not 3, 4. No, 3 units to the line. 1, 2, 3 units to the line. The image is going to go 3 units on the other side. 1, 2, 3 to here. Then this one at the back is 1, 2, 3, 4 units to the line. It's going to go 1, 2, 3, 4 units on the other side to here. And this one, same 4 units. 1, 2, 3, 4. It's going to go 4 again. 1, 2, 3, 4 to here. Those points are the points on my image. I just need to join them in straight lines. So I join this one. Join this one. Join this one. Join this one. So you do the first one. That's my shape. Let's leave it A prime. A prime. That is it. But the good. Next transformation I want us to do is a translation 4 -7. What 4 -7? This 4 -7 means 4 units to the right, 7 units down. That's what it means. Move the points 4 units to the right, 7 units down, and the shape is still the same. So all we need to do is move one shape, 1 point, 4 units to the right, 7 units down, and then draw by the same shape around that point. All right? So that's how we're using this point here. So let's say we're using that point. 4 units to the right. 1, 2, 3, 4. 7 units down. 1, 1, 2, 3, 4, 5, 6, 7. So this point is coming right here. And then all I have to do, this is 4 units to the right. This is 7 units down. That's a -7. And all I have to do now is draw by the same shape around that point. So this point across from it is going to be right here. And this is 2 units down that side. This is 2 units across here. And then you have this diagonal piece that completes the shape. And that's my image. And then someone's label this one A double prime, right? A double prime. A double prime. So label this A double prime. And we're done. That is it. But the good, easy question. Easy question. All right? Let's continue. Number 4. Number 4 gives us this function. Gives us f, gives us g, and it gives us h. 3 functions. What they want us to do? They want us to state what the value of x will make f undefined. So this is a fraction. Can't work out, it becomes undefined whenever the denominator is 0. So that value of x cannot be in the domain. That's what undefined means. The value of x that cannot be in the domain because it can't map onto any value. So it is undefined. It is undefined when the x plus 2 becomes equal to 0, which is when the x equals -2. And this means that -2 cannot be in the domain. It means that -2 cannot be in the domain of f of x because it don't map onto any value. It cannot have a value in the domain that is not mapping. It cannot be in the domain of f of x. All right? That's what it means. -2 cannot be in the domain of the function because it will not be able to map to anything. And it cannot have a free element in the domain that is not mapping. All right? Huh? And sometimes CSEC asks that too, what value cannot be in the domain? The same thing, the value that will make the function undefined. All right? All right. Let's continue. It says find g of a quarter. That's right, what g of x is. G of x is just g. G is 4x minus 5. So g of a quarter means that we put in a quarter there. So g of a quarter, that's right beside it here. So g of a quarter becomes equal to 4 times a quarter minus 5. It becomes 1 minus 5, which is -4. Good? That is it. Next question. They want h of -3. What is the h of x again? The h of x is x squared plus 1. Let's write it out. H of x, remember, is x squared plus 1. So I put the -3 in there now. So this is going to become -3 squared plus 1. -3 squared is 9 plus 1. 9 plus 1 is 10. That is equal to 10. What I got? Next part, we want f of 0. What is f again? F of x, remember now, was a fraction, right? It was 3 over x plus 2. It's 3 over x plus 2. Now, f of 0 could have been, this could also have been written, f squared of 0, right? Could have also been written like that as well, right? They could have given it this instead, mean the same thing. But f of f means you're going to do this f of 0 first. It becomes f of 0. And f of 0 means you're going to put 0 inside here. So it becomes 3 over 0 plus 2, which then becomes f of 3 over 2. That's what it becomes first. And then f of 3 over 2 means that you're going to put the 3 over 2 here, so now. And so it becomes now equal to, put it further over here. So it becomes equal to now 3 over 2 plus 2. That's what it becomes. 3 over 2 plus 2. Okay, all right, what that works out to be. It's 3 over 2 plus 2 multiplied by 2 over 2. It becomes 6 over 3 plus 4. It becomes 6 over 7. is the answer. Put in the calculator, that's what they're going to get. 6 over 7. Let's multiply up here so by a 2, sit here, to get that answer, I'm sure what I did. Quickly. I multiply the numerator by a 2, multiply the denominator by a 2. So 3 times 2 up here says 6. And the 2 times this 3 over 2 is 3. And the 2 times this 2 is 4. And then the 3 plus 4 is 7. And the final answer is 6 over 7. All right, so that is it. All right, that is it. All right, it said, must find out G of H. G of H, let's write them down. So remember the G now was, do the G again. G was 4x minus 5. And the H was x squared plus 1. And the G of H of x means the H into the G. That's what it means. It means that when I take all of this H and bring it and put it into the G right here with x is. That's where you put H into G. So creating that construct, it becomes 4. With x is, you put in all of the G of the H there, which is x squared plus 1. And then you subtract back this 5 at the end. And you're going to say simplify, simplify. It becomes 4x squared, that's 4 times x squared. Then it becomes 4 times 1 is 4, minus 5. Then the 4 minus 5 is negative 1. So it becomes 4x squared minus 1. That's the answer. And I want more stuff again. I want g to the minus 1 of negative 2. I showed you, most people for this one would calculate g to the minus 1 of x first. But I'm going to show you another way to do it again. All right? I'm going to show you 2 ways to do it without finding g to the minus 1 first. All right? So, what we can do for this one, we can say, okay, put this equal n, some number n. So we find any other answer. So that equal n, it means that negative 2 is actually equal to g of n. Let's write out what the g is again. G function. So g function was what? G function is this. 4x minus 5. So remember that the g is 4x minus 5, right? So back to this now. Using this method, we'll find it in. So we put this equal that first. Put it equal in. You mean that the negative 2 is equal to the g of n. Because if the inverse of g maps negative 2 to n, then g is going to map the n back to negative 2. Right? So if g to the minus 1 of negative 2 is n, then the negative 2 is g of n. And the g of n is when you plug the n into this. So you're going to get the negative 2 equals 4n minus 5. And then transpose that in the subject. Still have a transpose. I use this method or inverse method, you have a transpose. So you want to make this a subject now. Cure the 5 first. You get 5 minus 2 divided by the 4 over 4. That's equal to the n. That's 3 over 4. It's equal to the n. So I say when you find the n, you have the answer. So you can say, therefore, g to the minus 1 of 2 is equal to the n value. And the n value is 3 over 4. That's the answer right here. Or we can use the other method. Or we could use the method of find g to the minus 1 of x first, then we find g to the minus 1 of the negative 2. That's the other method. So for this method, we start with g equals 4x minus 5, and then we inverse it. We inverse it, g becomes x equals 4 times the x becomes g to the minus 1, minus 5. So instead of a transpose, I want to make this a subject. So go to make this a subject now, same thing. Pure the 5 first, you get x plus 5, and then divide another 4 over 4. That is g to the minus 1. That is actually g to the minus 1 of x. You can put in back of x now. And you can say now, therefore, g to the minus 1 of negative 2, you put the negative 2 here, so put negative 2 up here as well, becomes negative 2 plus 5, negative 2 plus 5 over the 4. Then the 5 minus 2 is 3. So you get the same answer. G to the minus 1 of the negative 2 becomes the same answer of 3 over 4. That's also the answer. So you have the option of doing it that way as well. Whichever way you prefer. Now let's continue. That question is done. Number 5, statistics. It said each of 75 girls, pay attention to this, 75 girls, don't lose, like the statistics you want, know how many, what the number of items you're working with, the number of persons, number of whatever. You want to know the data. So 75 girls. So n equals 75, the data. So 75 girls recorded the names of their favorite sport, the name of their favorite sport. It said the number of girls who chose track and cricket are shown on the bar chart. So we have the bar chart for track and cricket. So clearly the track is 12 up here. So let's put it up here. So the track is 12. And I put it in red. Track is clearly 12. So 12 girls like track. And cricket is clearly, let's look at the scale now. So this will be 14 right here. So if we were to complete it, here so will be 14. Right? Here so would be 18. But is it half in between that and that? And so this now is right in between the 16 and the 18. So that is 17. So right up here says 17. If we read the scale properly, right? If I finish these, right here will be 10. Right here will be 10 between the 8 and the 12. Right here so will be 6. Right here so will be 2. All right? So that is it. It says, how many more girls chose cricket than track? That's 17 minus 12. 17 minus 12. 17 minus 12, which is equal to 5. 5 girls more. That's the answer. 5. 5 girls more like cricket than track. And there were 17 for cricket and 12 for track. It says 11 girls recorded tennis as their favorite sport. Tennis was 11 girls. Let's put on the bar chart. We're going to need it to know. 11 girls for tennis. It's for the remaining girls. For the remaining girls, the number who chose swimming compared to the number who chose football is in the ratio 2 to 3. It says use the information to complete the bar chart. So we're going to find how many was remaining. All right? So let's look at it. So there are 11 who chose 11 like tennis, right? So tennis was 11. 11 for tennis, right? So the total we have so far then, total we have so far is 12 plus 17 plus 11, don't it? That's all? So that's what the remaining is. So the remaining girls, let's see what the remaining girls is. The remaining girls is going to be 75, because 75 girls was the total, minus the sum of the 17 plus the 12 plus the 11. That's remaining girls. So remaining girls equal what? Let's work that out. We have to break the remaining girls now in we have to break the remaining girls in the ratio. So it's 75 minus 17 minus 12 minus 11. So it's 35 girls remain. And those 35 girls is in this ratio, 2 to 5, 2 to 3, for a total of 5. So 35 girls now is in the ratio of that. So let's do the maths over here now. So the ratio question. So we can set up like this. I don't have a lot of space to work in, so I'm going to work it out right here. I don't understand why they don't give enough space to work. So use information to complete the bar chart. So we're going to get the total number of girls for each category and then complete the bar chart. So they don't give enough space to work. But let's do it right here. So it is what are the two sports again? Swimming to football. So swimming to football, 2 to 3. All right, 2 to 3. Swimming to football. The total is actually 35. So you can say that the swimming is 2/5 of 35, don't it? And the football is 3/5 of 35, don't it? But the total parts right here, so it's 5. Total parts right here, so it's 5. So this total of these two, the swimming and the football parts, is 5. But the actual total is 35. So to show the actual, you have to multiply this ratio by 5, by 7, I mean. Multiply that ratio by 7, you're going to get the 35 to multiply this by 7, you get the 14. Multiply this by 7, you get 21. So these are the actual number for football and swimming, 14 and 21. You could have used 2/5 of 35 to get the 14. I could have used 3/5 of 35 to get the 21. Right? So whichever way you do it, answer is going to be the same. But those are the numbers now for football and swimming. Swimming is 14 and football is 21. All right, so I can write them right up here. So let's put them up here so in purple. We'll work them out. So when I say swimming, becomes 14 and football becomes 21. All right, and the tennis is 11. So we need to complete the table now. The bar chart, I put in the rest. So let's draw them up in blue. All right, so the swimming for us is 14. So the swimming going up to 14. I have to use the same bar with all these, right? So the swimming coming up to 14 up here, so the 14 mark here, so 14. And this is a swimming bar coming up here, so draw that at the top of 14 up here. And then extend that down here. And this one as well. And then we can shade it. And the tennis is 11, right, God? The tennis is 11. Tennis is 11, so I'm going to come up to 11. So 11 is right in between. Oh. 11 is right in between the 10 and the 12 right here. So the 11 would be right across the middle here. So They come down on these lines. That would be your tennis. And then we need the football. Football is how much again? Football is 21. So we're going up to 21 for the football. So for the football, let's make sure this is 24. So right here will be 22. 21 is right in between here, so right? So 21 is right in between here, so 21 is right in between. So this is the bar for 21. The bar for 21 will be up here, so let's draw it properly now. Sketch it out first, let's draw it properly. So it's gonna be right in between here. And then come down on those lines. 21. We come down here. And then come down here. You can ask that one as well. Let's put the numbers on top. So this is 21 up here, 21. And this one was 11. And this one was 14. And that is your bar chart. Completed. Completed bar chart. All right, so that little ratio part of the question here. But they didn't give any space to work it out. That's the only thing about it. They didn't put any space to work it out. But that is it. Next part I said, determine the modal sport. The modal sport is the one with the highest frequency. It's clearly football, right? Football is a modal sport. One with the highest frequency, the one that has most people liked. Football. That's it. Just stand up. Well, just on the part. All right. Then down here now, it says one girl is selected at random. What's the probability that she chose neither track nor cricket? So if you chose neither track nor cricket, it means then neither track nor cricket. That means the other sports. It means swimming plus tennis plus football. That's what it means. Neither track nor cricket means the other sport. You want somebody who chose the other sport. So swimming was 14 persons for swimming, 11 persons for tennis, and 21 persons for football. See what the probability of getting one of these persons. All right. So probability becomes equal to 14 plus 11 plus 21 out of the 75 persons. That's how you work it. So that is a fraction 14 plus 11 plus 21 all over 75. And that other fraction becomes 46 over 75. That's the answer. Still have another point, I don't need. Next says, information of the favorite sport of the 75 girls is to be shown on a pie chart. Calculate the sector angle for football. Sector angle for football, I mean for football is 21. So it's 21 over the 30 over the 75, and the total angle in the pie chart is 360. So you multiply that by 360, so it becomes 21 over 75 times 360 degrees. That's the sector angle for the pie chart. for football. Huh? How much? 128? 100.8? All right. 100.8 degrees. Sure. Same thing I got? All right, good. On the bright, man, on the bright. You guys are bright. Next question, number 6. This question says, you must take pi square 22/7. Once you see that, you know you're doing circular measures. And the volume of a cone is 1/3 pi r squared h. 1/3 pi r squared h. It said the diagram below shows a sector OMRN of a circle with a center O and a radius of 12. And the sector angle is 168 degrees. Everything that I've said up here in the words is in the diagram. So good. And it says it forms a thin sheet of metal. It says calculate the perimeter of the sector above made from the thin sheet of metal. So the perimeter is going to be the length of the radius, the two radii, plus the arc. See that? And put on the 12 on this side. So this side is also 12 centimeters. And remember the arc length is theta over 360 times 2 pi r. Remember that? Theta over 360 times 2 pi r. So the perimeter equals the perimeter that I want equals 2 times the radius. I can also 2r. Radius plus the radius, that is 2r, plus the arc length. And the radius is 12, right? So the r equals 12. R equals 12 centimeters. R equals 12. So put it in the values now. So it becomes equal to 2 times 12 plus, and the arc length in the same formula up here. So theta is 168. Theta over 360, that's 168 over 360 times 2 pi r. 2 times pi, the pi is 22/7, right? 22/7 using for the pi. So it's 2 times 22/7 times the r, which is 12. That's what we're working. Put that in the calculator and get the answer. One calculation. And so it becomes 24, that's a 2 times 12 here says 24, plus fraction 168 over 360. And then multiply that by 2 times a fraction 22/7. And then multiply that now by 12. I'm going to get 59.2 centimeters is the perimeter of that sector. The distance all around it is 59.2 centimeters. Better go to that. All right, beautiful. Next part now says the cone, a cone is made from the sector by joining OM to MN as shown in the diagram. So this up here was the net of a cone. That's what we call the net of a cone. And if you can imagine that, you like take the middle section right here and you pull it up towards. Imagine that you have this thing flat on the table. And take the middle section and you pull it up towards you. And these two ends go around and they join. This end and this end come around and they join each other. They join together. It's this end, this point, and this point. Well, as you pull this one up, these two come and join. So when they join together, they form this shape. That's what they get. That's what they get. Let me copy this up here so we can get some relevant information. I'll delete this first. And then copy this and show you some relevant information. From it. So this is the min. Right? So if you zoom up here, so what happens? What happens? I'm gonna use the colors. I'm gonna use the colors, right? So what happens is that this piece here that I'm marking out in purple, this arc, becomes the circumference of the base of the cone. But you can see that? Right? That arc becomes the circumference of the cone. Right? But I say that? And then what happens now is that this side that I'm marking out in red, this piece and this piece, they are now joined right here. Come together to form this piece right here. So that's when the M and the N join right there. And then the O now is at the top of here. So can I appreciate that? That's what happens when you take this middle piece and you pull it upwards towards it goes up there. And then this and this join together and they form the thing there. So if I shift this over this side, all right, just use this. So this becomes that. And this piece becomes that. I'll put over the next side then. Put over the other side. All right. So try to understand it. So this piece is now became that, and this thing became that. That's what happens. All right. So the R of the sector is now the circumference, and then this slant length is what this radius was. It was 12. So that height is still 12. That red piece is still 12. But understand that? Good. So just remember this was 12. So this is still 12. This is now 12. And then this arc length, remember the arc length was what was the arc length again? Did we calculate the arc length separately? But they work out everything in one, don't it? This was the arc length, don't it? So if we work it out right here, so we can work it out up here so we can know what it is as a value. So it would be equal to 168 over 360 times 2 times 22 over 7 times 12 is equal to, let's work it out so we can put on the diagram. So I'm taking off this 24 and it becomes 35.2. So it's 35.2 centimeters. That is the arc length. So the arc length was 35.2 centimeters. So this was 35.2 centimeters. This purple piece was 35.2 centimeters. It is now what the circumference is. 35.2 centimeters is now the circumference. So those are the dimensions that are transferred from the sector to that cone. But understand that? Make sense? All right. Them some must calculate the radius now. So you now calculate the radius. To calculate the radius, we're going to use the fact that the circumference of the base is now 2 pi r. Circumference is now 2 pi r with this r right here. So this circumference down here, so now 2 pi r is now equal to that circumference. I can put it right here. This circumference is now equal to 2 pi r. This circumference is 2 pi r, this r, using this r. Right? So the r up here is different. The different r up here. So we have r on this diagram in the formula, but A different R down the bottom here. We're talking about this R. So to calculate that, we're going to use the fact that the 2 pi R now is equal to this. So it's 2 pi R is now equal to 35.2. So the R equals 35.2 over 2 pi. And the pi is 22 over 7. Shift this over. So it becomes equal to 35.2 over 2 times 22 over 7. That's what we're working now to get the radius. All right, so it's a fraction 35.2 over 35.2, Mr. Shaw, over 2 times a fraction of a year, 22 over 7. 5.6. That's 5.6 centimeters is the radius of the base of the cone. Understand that? Understand the calculation? So we transfer the arc length, the arc of the sector is now the circumference of the base of the cone. And circumference of a circle is 2 pi r. So the 2 pi r is now equal to the 35.2 centimeters. The arc is now the circumference of the base. Then I want the height. To get the height, now we're going to work in this triangle and use Pythagoras theorem. See that? We're going to work in the triangle and use Pythagoras theorem. So what we're going to use now is that the 8 squared plus the r squared is equal to 12 squared. What is that? In the right angle triangle. Pythagoras theorem. So the 8 is going to transfer the r squared and then take square root. So the 8 is going to become the square root of 12 squared minus r squared. Pythagoras theorem. And r is 5.6. So the 8 becomes equal to the square root of 12 squared minus 5.6 squared. Hello. Hello. What's up? Equals. Let's work this out with the calculator now. So it's square root of 12 squared minus 5.6 squared. I'm getting 10.6. 10.6 centimeters is the answer. Height of the cone. Very good. If you didn't get it, go and work it over back. All right. Next part says, calculate the capacity of the cone in liters. Remember, to get it in liter, remember that 1,000 cm cube is a liter. 1,000 cm cube is the same as 1 liter. All right? So we're going to calculate in cm cube first and then divide by 1,000 to get liters. So the volume, the capacity is the volume, right? Capacity is the volume. Capacity is volume. Capacity is volume to full. Volume to full something. So that volume is 1/3 pi r squared h. The r is 5.6 centimeters and the h is how much? The h is 10 centimeters. 10.6. So it's 5.6 and 10.6 to get? Yeah, 5.6 and 10.6. So putting those values in here. So the back volume becomes 1/3. The pi is 22 over 7. The r is 5.6 and you're squaring it. That's r squared. And then multiply that by the h, which is 10.6. And I get the volume in cm cube. Let's work it out right here. So it becomes 1/3 times fraction 22 over 7 times 5.6 squared times 10.6. That becomes 348.2 centimeters cubed which then becomes, you divide by 1,000. You get divided by 1,000. You move this decimal point 1, 2, 3. So it becomes 0.3482 liters. And that is the answer right there. Very good. Move the decimal point 3 places to the left to get it in liters. That divided by 1,000. All right, that is a nice question. I like it a lot. I like it a lot. Number 7. The pattern question. It says a sequence of design is made using black disc and white disc. The first 3 designs in the sequence are shown. It says in the space provided, draw diagram 4. Draw diagram 4. All right, so let's look at it. They keep adding one block on the vertical. So on the vertical, we need 5 blocks now, 5 dots now, right? 5 blocks on the vertical. And they also they skip 2 spaces to put the next one. So skipping 2 spaces with the next one. So I'm going to use the blue. So we need 5. 1, 2, 3, 4. That's not going so straight. Let's go again. 1, here. 1, 2, 3, 4, 5. Then a white on top. Then on the bottom, I keep adding 1 more. So it was 2 to the right of it, then 3 to the right of it, and then 4. So we need 5 to the right now. 5 to the right now. 1, 2, 3, 4, 5. Then I complete the space inside there, so with white. So we have white, 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 white. That's your figure 4. Very good. Hear that? Beautiful. Next question says, the number of white disc W and the number of black disc B and the total number of this T form each diagram follow a pattern. The values of W, B, and T for the first 3 designs are shown in the table below. So the pattern of numbers in the table and then complete rows for 1, 2, and 3. All right, let's go. So I like to complete the bottom line, the end line first. So you observe. All right, so these numbers are the pattern numbers. That's the pattern numbers again. That's the pattern numbers again. And then they add in 1. So it's pattern number times pattern number plus pattern number plus 1. Let's do it. Pattern number, which is n, times pattern number, which is n in the bracket, plus pattern number plus 1. Now what will this work out to? This work out to n squared plus 1 plus n plus 1. That's what it will become. N squared plus n plus 1. If you put that equal. But I think if you left this alone, you'll be fine. That's a pattern. For this one now, what's happening over here? Everything jumping up by 2. Plus 2, plus 2. So this one kind of easy. Plus 2. So if it's a plus 2, it starts with 2n. The formula starts with 2n. And 2 times 1 is 2. You have to add 2 to make 4. So it's 2n plus 2 is the formula. 2n plus 2. Then over here now, is this increasing by anything? This is the total, you know, so I know that it's the sum of this and this. 3 plus 4 is 7. 7 plus 6 is 13 and so on. But is this following a pattern by itself that we can pick up? Is it an increasing pattern? Altogether, we cannot add this, you know. Just add this and this, you know. Just add them. Because that's what this is. This is some of these two. So remember, it's the total. The total of the white and the black this. So we don't have to kill yourself. Just add this. This is the expression for the white. That's the expression for the black. Just add them. So just gonna add them. Write it down here. So just for this column, we're just gonna do n squared plus n plus 1 plus 2n plus 2. What do we get? We're going to get n squared is the only n squared term, n squared. Then n plus 2n is 3n plus 3n. And then 1 plus 2 is 3 plus 3. And that is that. Done. Then we're going to need to complete this line now. So for this one, the n equals 9. So remember, it's n plus 1. So it's 9, 9, 9 plus 1. So this is 81 and 9 make 90 and 1 make 91, don't it? So 91. I work out to 91 for 2. And I get 91 too. Oh, right. Then for this one now, you take the 9 and drop on the formula. You get 2 times 9 is 18. 18 and 2 make 20. So this one is 20 right here. So what I go to that? They already give you that one, so you're not going to work out anything. Then here now, clearly the n is 20, right? So I'm going to put 20 over here, so the n is 20. Then we're going to take the 20 and drop it on this formula. 2 times 20 is 40 plus 2 make 42. So right here, so it's 42. Also, we're going to drop this n on this formula, the 20 on this formula down here, so 2. Let's work out what we're going to get for this one. Let's work out what we're going to get. Let's work it out. Let's show the examiner what we're going to get. So right here, we're going to get 20 squared plus 3 times 20 plus 3. 20 squared plus 3 times 20 plus 3. That's what we're going to put inside here, so. That's what we're going to put in here, so. The 20 squared is 400, don't it? And then 463? 463. 463, yeah. 400 plus 60 plus 3, 463. Are we done? Yeah. Make sure all the cells are completing. Don't leave out none where you're supposed to complete them. So sometimes people come out and them left out all like that. They forget, they don't see. But pay attention. Make sure you complete all the cells that you're supposed to complete. For this? You put W plus P. No, you have to give it in terms of the N. You have to give it in terms of the N. Alright? You put W plus B down there. That's what you put there, W plus B. You have to give it in terms of the N. Alright. That's how the mock exam. You get something like this next time. Could be something very subtractive. Alright? So let's go. Next part now says Stephen has 25 black discs and 154 white discs and wants to make design 12. So design 12 is when n equals 12, don't it? That's all? He said, explain why it is not possible for him to make design 12. So when I look and see how many black him need for design 12 and how many white him need, and see which one of them violated, right? So for design 12, the W, remember, was equal to what again? The white disk was equal to what? This formula, right? N squared plus n plus 1 is n squared plus n plus 1. Which will be equal to 12 squared plus 12 plus 1. What that work out to? That's 144. That's 144 plus 12 plus 1. That's 157. So you need 157 black. You need 157 white. You only have 154. You don't have enough. See it? So this is what he needs. He needs this amount of white, 157 white. I'm going to work out the black too. It needs how many black? He needs the black to be, black was what again? Black was 2n plus 2. 2n plus 2, which is 2 times 12 plus 2. That's 24 plus 2. It's 26, right? So it might have enough black, but not enough white. See? Not enough white. Not enough white. Huh? Can't make it. Huh? Oh, it might have 28 blacks, it might have enough black. It only needs 26 black. It have enough black. It needs 26 black. Yes, 28. But it don't have enough white. See it? He needs 157 white. He only have 54. I'm short. So not enough white. The black okay. The white is short, right? Short by 3. Right? He needs 3 more white. Right. It needs 3 more white. Need 3 more white. Remember, you know, the pattern of have the right of white and black. You know? So I have 28 black, and I only need 26. I have enough black. But I have 2 black extra when I'm done. But I have enough white. I only have 157 white. I only have 154 white. I need 157. So I need 3 more white. Done. Next question. Quadratics. And that's a front-shaped quadratic. Oh, no, because the square term is negative. Remember, it's a quadratic function. Its values are symmetrical. All right? Once the value, especially when once you see these values increasing by the same interval, which is by 1 in this case, then the y values are symmetrical. So you're looking for the like values in this and for the symmetry of the values. All right? Well, they don't give me the same value right here, so I'm going to do some calculation. I for calculate so. And they don't give me anything. They don't give me any other values here. So I have to calculate something and then look for the symmetry. All right? So let's say they want us to complete the table for this function. Let's say we're working out for 1. Let's say we're working out for x equals 1 right here. By plugging the 1 in this. For x equals 1, the y becomes equal to negative 1 squared plus 1 plus 7. Which works out to what? 6, right? That's 6. No, 7. This becomes 7 too, don't it? It becomes 7. Don't put to go now, you know. This negative 1 square, remember, you know, you only squaring the 1, guys. You're not squaring the negative. So don't become a positive 1. See that? You only squaring the 1. Right? So that becomes a 1 by itself, and then this makes it a negative 1. So that becomes a 7. So it means that right here is a 7. So once right there is a 7, we can use the symmetry of the values now. Watch this now. To the right of this 7 is a 5, so the left of this 7 is also a 5. See that? Then now to the left of this 5 is a 1, to the right of this 5 is a 1. And the values are symmetrical. Then now to the right of this one is negative 5, so the left of this one is also negative 5. But I said that? Now have to calculate all the values, and the values are symmetrical. Now know that the values are symmetrical, my line of symmetry is right between these two sevens. See that? So I'm going to put it in with this red line. My line of symmetry becomes right here. My values are symmetrical about this line in the middle right here. So see that? The values are to the same to the right and to the left of that line. The y values I'm talking about. So based on that, I know that that red line represents my axis of symmetry. And it is right between the 0 and the 1. What comes right between 0 and 1? Half. Then average them. That's the x value, the turning point. So it means that xt right here means that xt is equal to half. And to find the yt value, I can calculate what the y value is right here. The y value is by plugging in a half in the function. That's a yt value. So yt can plug the half in there. Let me move this down some more out of the way. This calculation for the 7. And then calculate the yt here. So So the YT now I'm calculating here. YT is when we plug in the half in the function. Becomes minus half squared. Remember, you're not squaring this minus. Plus half plus 7. So the y by the turning point becomes what? That's a half minus a quarter. Half minus a quarter is a quarter. Becomes 7 1/4. 7 1/4. That maximum point becomes 7 1/4. That's a half minus a quarter is a quarter. Plus 7. So you get 7 1/4. It means that my maximum point, before we start working the things, xt, yt is the point half 7 1/4. Half 7 1/4 is my maximum point. All right. Graph question wants us to draw the graph now, right? Let me copy this down with the points on it so we can just have it in front of us. Some of us use the technology. Let's copy this down. With the values in there. Put it up here, so it's right in front of us. All right. So let's plot the points now. Did they put on the grid for us? Yes, they put on the grid and they put the scale it up first, not the grid, they scale it up first. All right, so the values are -3, -5. -3, -5. -3, -5 is down here. -3, -5 is down here. So this point. Next point. -2, 1. -2, 1. -2, 1 is right here. -2, 1 is right here. Next point. -1, 5. -1, 5 is all the way up here. -1 up to 5. It's right here. -1, 5. It's here. Next point. 0, 7 is on the y-axis right here. So 0, 7. Next point. 1, 7. 1, 7 is right here. Next point. 2, 5. 2, huh? Oh, that's not 1, 7. Oh, 1, 7 is here. Thanks. Here says 1, 7. Then you have 2, 5. 2, 5 is right here. The next point is 3, 1, right? 3, 1 is here. The last point is 4, -5. 4 down to -5 here. You're going to put in the maximum point. What's the maximum point again? Half 7 1/4. Half 7 1/4. Let's put on that one in the ring. Because they didn't give us that one. So this is a half line. See? This is half. This is a bit half. That's x equal half, and that's axis of symmetry. Let's draw it in. Let's draw it in there. All right, that's axis of symmetry right there. And the maximum point is on it. So we need 7 1/4. So this will be 7 1/2. So 7 1/4 is about here, so don't it? So it's right here. It's a maximum point. 7 1/4. So I'm going to mark that as the maximum point. It's a maximum point. Half 7 1/4. And draw the smooth curve through those points now. So I'm going to draw a curve through those points, guys. Best way I can with this device. So draw this half of it over here. And I'm just going to draw this half of it over here. Not so good. Not so good. That's so good. I look better. All right, I work with this. All right, that's it. That's my curve. What else I want us to do? Draw the curve right on point of the maximum point. Half, 7.25. That's it. You have to practice to do those points. No matter the naturally give it to you, but you can just get it like that. The one you could calculate the XT and the YT minus B over 2A for the XT, 4AC minus B squared over 4A for the YT. So we calculate them as well. But when you get the values in a table like this, it's kind of easy. Kind of easy to do. When you get the values in a table like this. All right? That is that. Next question. Write down the equation of axis of symmetry. That is that red line on the graph. X equals XP. See the axis of symmetry, this line. Axis of symmetry. X equals half. Same line up here, we'll put on the table, represent the axis of symmetry. X equals half. X equals half. Let's write it down. X equals XT. What? X equals half. Put over here, so. X equals half. That's the equation of it. Use your graph to find a solution for this. That's where the graph intersect x-axis. Those are the roots. The graph intersect x-axis. That's what I want. All right? So these are the roots. I'll give you the roots. The roots. Talking about the roots. Roots are the points of the graph intersect x-axis. When you solve the equation, you get in the roots. So you're finding those points on x-axis. Let's see if we can estimate them. But these are my roots. So this is one of them. That's the other one right there. Let's estimate it. So this one looks like this is 0.1, 0.2, 0.3, 0.4. So this looks like about 3.2. That's one root, 3.2. This is the other root. That's negative 2.2. Negative 2.2. X equal negative 2.2. That's what I'm giving them. Negative 2.2 and 3.2. But that's right, that's wrong. That's what the graph from the graph says. X equals negative 2.2 and x equals positive 3.2. That's what we're giving them. Next one. On the grid and page, draw a line through these 2 points and then determine the equation of the line. Wow. So on the line through negative 3.1 and 0.8. So 0.8 is the C, right? This is the C. That is the C. C equals 8. And then we're gonna need the equation. So negative 3, 1, negative 3, negative 1, and 0.8. Negative 3, let's put on in purple. Negative 3, negative 1, negative 3, negative 1, and 0.8. So negative 3, negative 1 is here. Negative 3, negative 1 is here. And then we need 8, 0 is here. It's pointed 8, 0. No, 0.8, I'm saying, not 8, 0, 0.8. 0.8. Y-axis intercept, 0.8 is here. So we need a straight line through those points. So we're gonna just draw a straight line through the points, like a tangent line. Looks like a tangent right here. See that? Looks like a tangent right here. So to find the gradient of that, find the gradient of that, we can count the right and count the wrong. No, look at 8 now. We can count the right and count the wrong. So on this line, the rise is equal to, let's count how much you go up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Rise 9. Rise 9. How much error come across? Rise 9 and now come across 1, 2, no. Check the grid. Horizontally is 2 units is 1, right? 2 boxes is 1 horizontally. So we run 1, 2, 3. Run 3. So going to right over run 9 over 3, which is 3. So going to that line is 3. So don't have to know the grid of the line is rise 9 over run 3, which is 3. Note, guys, the run was not just counting the grids. You have to count the interval. Horizontally, one interval was 2 boxes. See that? You're counting the units. 1 unit was 2 boxes horizontally, while vertically, 1 unit was 1 box. See that? So horizontally, the run was 2 boxes make 1, 2 boxes make 2, 2 boxes make 3. So the run was 3 units, even though it's 6 grids. 6 grid lines go across. But be careful. So the run is actually 3. In fact, you're going from -3 over to 0. That's a run of 3. All right? So be careful with that. So the greatest is 3 and the C is 8. So the equation is y equals mx plus c. So it's y equals 3x plus 9 is the answer. Plus 8 is the answer. C is 8. Done. I don't want to stick on that one, but that's it. Very good. All right. Number 9. Circular measures. Question says L, M, N, and R are points on the circumference of a circle. Center O. PQ here is a tangent. You're thinking tangent and radius, tangent and chord rule. Right? And it says angle PRL is 48 degrees right here. That's the angle between tangent and a chord right now. It's 48 degrees. All right? It says angle RON, that's the angle at the center, is 156. Remember, angle at center is twice angle at circumference. The angle at center is twice angle at circumference. Remember also that this is an isosceles triangle. But this is a radius and that's a radius. So it means that these two angles are the same. Angle down here and down here are the same. All right, remember those things, guys. Remember those things. All right. It says, find the value of each of the following angles, giving reasons for each of your answer. Show all working where appropriate. Angle R first. That is this angle up here. So angle R. Let's look at it. Angle R. All right. So angle R. Angle R right now. We come back to where you meet the circumference. Angle R is subtended by this chord. Or I could say it is subtended by this arc. Let's work with the chord. Same chord is subtending this angle of 156 at the center. The one at the circumference is twice. The one at the center is twice. The one at the circumference is half. So R is half of 156. But the angle at the center is twice. The angle at the center is bigger by 2. So center rule we're using. So this angle out here, so it's half of the 156. All right. Let's go. 78, you say? Let's put on the diagram. 78 degrees. All right, let's write it out though. So angle R is equal to half times 156 degrees is 78 degrees. Center rule. Angle at the center, which is the 156, is twice angle at circumference. And that's why that angle there is 78 degrees. Next angle I want is what? Angle E. Let's look at it now. Angle E. So angle E now is equal to the 76 same way. Why? Because the angle E is the angle between this tangent, put it in red for you. Angle E is angle between this tangent and this chord. That's what angle E is. An angle between a tangent and a chord is equal to the angle subtended by the chord. And the chord is subtending the 78 up here, the circumference. So them two angles are equal. Angle between a tangent and a chord is equal to the angle subtended by the chord. So that angle is 76 degrees, 78 degrees as well. So angle E is 78 degrees as well. Put on the diagram. So this angle down here is 78 degrees. All right, so I'm going to write that. This angle is equal to 78 degrees because angle between a tangent and a chord equals angle subtended by the chord at the circumference. If you leave this, you get that, if you get the marks, if you just leave that alone, you get the mark. You could finish it and say at the circumference. At the circumference. In the alternate segment. Guys, study the rules. Make sure you know how to write the rules. Write the rules the same way every time. If you just stop it right here, so they give it a marks. Angle between tangent and chord equals angle subtended by the chord. Next thing you want is angle A. Angle A. Let's look at it. Angle A. This one over here, so no. Angle A. All right. So angle A. All right. So angle A is opposite to this angle inside here. So we can look at it as a cyclic quadrilateral. Mark it out for you. Angle A is an angle in this cyclic quadrilateral. So these two angles that I'm marking out in blue, the A and this angle, they add up to 180 degrees. So, and then now, total angle on this straight line is 180 degrees as well. So what's gonna happen is that the angle A is gonna be equal to the sum of these two. Because if these two add up to 180, and then them total angle on straight lines are also add up to 180, it means then that this angle over here is equal to the sum of those two. But you could use a method of finding this one in here so first, this one in here so first, which is 180 degrees minus the 78 and the 48 together. And then over here now becomes 180 degrees minus that angle down there because of the opposite angle inside the quadrilateral. 180 degrees minus whatever it is. What is work out to? It says 54. So it becomes 180 minus 54 as well. It becomes the sum of those two anyway. What that work out to now? That is 116. 7 and 4 is can't be 116, man. 126. 126 degrees. All right. So I'm going to find this angle first by saying total angle on a straight line is 180. You can put it here, sir, now. Total angle on a total angle on a straight line is 180 degrees. That's how I do this calculation. Then over here now, get 126. You want to say opposite angles in the cyclic, quadrilateral, or supplementary. Mean that they add to 180 degrees. So that's how we get the 120. So those are the two things that we work to get that angle. So we need to get this done on the paper. So you have to tell them, so firstly, what angle name? NRL. Angle NRL first. So first, what I say, angle NRL is equal to the 180 degrees minus the same calculation that we did up here. Let's copy this down. Copy this down here. Same calculation. Angle NRL is this. And then the other one now, this one over here. Angle that we want. This angle over here. Put this one down here, so now. That's the angle A, or the alpha. The angle A equals that. Alrighty, that's it. Then we'll come to this. Bearings. See the north line there? So bearings. Diagram below shows a triangular field LMP on horizontal ground. Calculate the value of angle MLP. So all dimensions are there. So MLP is the angle inside there. So let's call it theta. I can call it alpha since it is inside. Let's call it angle alpha. Put on the diagram alpha. We want to calculate it. So to calculate the angle, we have to use cosine rule. When you have three sides in a triangle, that's not a right angle triangle, use cosine rule. So to use cosine rule, they're going to use the side opposite from it, treat it like the hypotenuse. So remember, cosine rule start out like Pythagoras theorem. We start out like that was the hypotenuse, and this was the 90. It start out that way. All right? And then these now become the two sides in between, the two sides with the angle in between. We'll set out the right way. So treat this like the side opposite the angle in the cosine rule. So cosine rule. Start like Pythagoras theorem. So that the 180 squared will be equal to the 150 squared plus the 120 squared. That's how it would start out like Pythagoras theorem. If this was the hypotenuse. But it's not Pythagoras theorem. So we subtract a piece. So you subtract twice the 150 times the 120 and the cosine of an angle between them, which is the alpha. They have to transpose now to make that alpha the subject. And the practice, you can do this transposition in one step. Because what happens is that all of this come over onto this side first, and then the 180 squared come over onto this side and subtract. So let me copy this over this side, copy it first, and paste it over here. Come over here, so positive. And then all of this come back and change. They get equal 150 squared plus 120 squared. And then this now come over here, so I subtract. They get minus 180 squared. The next step now is that all of this thing now is divided under this side, divided under. So I'm going to move it under there for you. So all of this gets divided under this side. And here's my division line right there. Want to go to that? So cos alpha is now equal to that, right? Let me make this a little smaller. shift this both side out here. So. All right. And then what happens next now? We're going to take the cos to the minus 1 over here. Right? So when you take the cos to the minus 1 over there now, you're going to get the alpha equals cos to the minus 1 of everything right there. So CSEC, you don't get a lot of speed to doing a lot of transposition. So you have to be very efficient. See that? And then you put this in the calculator and you get the alpha. Put that in the calculator and we get our alpha. Put this in the calculator, get the alpha. Says cos to the minus 1 of a fraction 150 squared plus 120 squared minus 180 squared divided by 2 times 150 times 120 under there. And angle is 82.8 degrees. 82.8 degrees. That's the angle, 82.8 degrees. Better go to that. Anybody got it? One, bright. Good. Next question. It says the bearing of P from L is 210 degrees. Just put that 210 degrees on the diagram. P from L. Pay attention, guys. It is from L. It's from L to P. From L to P is 210. Show it on the diagram so you can see what you're working with. So it's from L down to P is 210. That angle becomes the clockwise angle all the way around here. That is the angle that is 210 degrees. Remember that the angle in here for the alpha is what? 82 point how much? 82.8. They put it in here. This is 82.8 degrees the alpha is. Right? And all the angle around is 210. Right? Let's see what they want now. It says find the angle of M from L. They want the angle now of M from L. So it's from L to M, they want the bearing. From L to M. Let's put that on the diagram and see what angle that will be. So it's from L down to M. Easy. So from L to M would be, I'll put the 210 somewhere. It would be this angle down here, so clockwise on. So that's the angle that I want. That's the angle that I want. I'll put it 210 somewhere. Let's put 210 all the way here. So put this, so 210 degrees. So the bearing that I want now is this angle. This angle that I want, the bearing. That's the angle that I want next. Let's call it angle theta. And that angle theta is simply going to be, the whole thing is 210 minus the 82 point. But can you see that? So it's 210 minus the 82.8 degrees, which works out to what? 210 minus 82.8, you get 127.2 degrees, but bearing is given to 3 digits, right? So you're going to put 127. So it's on the diagram. So when I say it is theta, so this angle we're calling it theta, and the theta is 210 degrees minus 82.8 degrees. We're getting 127.2 degrees. Gonna write theta equals 127 degrees as our answer. The bearing angle, 127 degrees, 3 digits, leave it with 3 digits. What is good? All right, what else they want? Calculate the angle NLE and hence find the bearing of L from P. What do I want the bearing of L from P? Let's put on that one in blue on the diagram. We don't have anything on the diagram in blue yet. Well, have the angle in blue. So from P to L, we want the angle. And the kind of guide us how to do it. We would have to do it that way actually. You know? From P to L, let's see what that is. From P to L, I want. So I want the bearing going back up this way. From P to L. Right? And they tell us to find its angle base first. See that? That's what they say. No? You know, say you don't have to do it that way. Watch this. Watch this. They want the bearing up this direction, right? So the north line here, so. You see the angle that you want, don't you? You want the bearing up this direction. That's all. You could find it up here so too, you know, watch this now. You want the bearing up this direction. The same direction up here, so. Bearing up that direction is this angle right here, so you know. See that? That's the angle that I want, you know. You can find it up there so too. But that angle will be what? How can you find that angle? So it's that straight line, right? And from here, so this is 210. So it's actually 210 minus 180, you know, is the answer, you know. 210 minus 80. If you could actually find that bearing angle up here, the forcing us to find it down here, we could have found it up here as well, as I just showed you. Show you again. But remember, bearing is just a direction. So instead of finding it down here, so I could just say, okay, I want the bearing of this direction. So let's extend this line through here. Extend this line, this direction through here. I want the bearing of this direction. That's a bearing of from P to L. From P to L. Right? From P to L is this angle. That angle, and remember that's a straight line, you know, guys. So it's 210 minus 180. What I'm saying. Hello? No. I'm using the phone for that spot. All right, so about that. All right. So we can find that angle. So that being angle up here that I want would be 210 degrees minus 180 degrees, which is 30 degrees. I put a 0 in front. So that's exactly 30 degrees. That's here 30 degrees. You know? But the question is forcing us to find this angle base first and then use the co-interior angle to do it. They want us to find it down here from down here, so. So they want the north line here, so. And I want us to find it by doing this angle. But I want us to find this angle here, so first, where this angle inside here would be what? 360 minus 210, don't it? Don't it? So this angle inside here would be 360 degrees minus a 210 degrees. How much is that? How much? 150 degrees. And then these two angles now add up to 180. Co-interior angles. See that? So that's how I get the 30 same here, but easier up here, so. Easier. So this angle now that we want, being that the one, it's not going. The angle inside that I want would now be 180 degrees minus 150 degrees, which is equal to 30 degrees, and put a 0 in front, it's same way. That's the calculation that they're telling us to do. We could have worked it out up here quickly just to see. So anyway, so the angle up here that I want is 150. NLP, right? Let's say find angle NLP. Angle NLP is 360 minus 210 is equal to 150 degrees. Then the bearing of L from P, let's call that angle something my reference. Yeah. Angle L from P, let's call it phi on the diagram. This is angle phi over here. phi. Right? Angle phi. And then build up L from P. Therefore, phi will be equal to 180 degrees minus the 150 degrees to be equal to 30 degrees. We'll put a 0 in front of it. Leave that as the answer. All right? That's it. Question done. One last one. One last one. 7:30. We're not coming. Matrices, transformation. Question says, matrices A and B represent transformations. This one is A, which you should know. That's an anti-clockwise 90-degree rotation about the origin. See, they tell you. And this one you should know is a reflection in line y equals minus x. And they tell you. But you should know these matrices. Some questions are going to help you and give them to you like that. You need to know them. He said, determine the elements of a matrix C, which represent an anti-clockwise rotation about 90 degrees about the origin, followed by a reflection line y equals minus x. So this is A followed by B. So C equals A followed by B. A followed by B is B times A. Second one than the first one. So the C equals BA. Remember, guys, A followed by B is BA. You get a single matrix. So you multiply the second one by the first one. You're supposed to know what you're going to get. You're going to get the Y equals X reflection. No, lie. No, lie. That's not a 180-degree rotation. That's a 180-degree rotation. So you get in either, you're reflecting a Y equals, either get in the Y axis or you get in the X axis. One of the two of them. But let's let the mathematics work out itself. So the B is -1. No, sorry. 0 minus 1. 0 minus 1 minus 1, 0. And the A is 0 minus 1, 1, 0. And remember, you multiply the rows of the first matrix with the columns of the second matrix. So this is going to be equal to either the y-axis reflection or the x-axis reflection. Let's put in the values. So this value first is this row and this column, right? This row times this column. So it's 0 times 0 and -1 times 1. That's that -1. So this value is a -1. Then this value over here is this row and this column. So 0 times -1 is 0, and -1 times 0 is 0. This value is 0. And this value down here is this row and this column. So -1 times 0 and 0 times 1 is 0. Then the value down here is this row and this column. With -1 times -1 is a +1. And 0 times 0 is 0. That's a +1. And you should know that that is a y-axis reflection. Reflection over the y-axis. See? Describe a single geometry transformation for C. Reflection in the y-axis. A reflection in the y-axis. So you see, even though they give you two and tell you what they are now asking you a question that you should know what it is. Same way. So you still have to know them. All right? You still have to know them, guys. You still have to know them. All right. What else? This one says transformation T is defined by this. K is a constant. It says T maps this value onto this value. Find the value of K. It means that when you apply the matrix to this point, the answer is this point. That's what it means. It's an equality of matrices set up for you. So you're going to set it up this way. 1, 2, K minus 1 times the point 2, 3 is equal to the point 8, 15. That's what is happening. Right? Because the point 2, 3 is mapped by T onto the point 815. So how it works is that you multiply the point by the matrix to get the image point. So you apply the transformation to this point is equal to that point. That's how it's set up. So you basically set up an equality of matrices. I'm trying to find this key down here. So we can do something like this. We can say this 15 under here is the product of this row and this column. Set up like that. Right? So we can say, use the red, the purple. I said K minus 1 times 2, 3 is equal to 15. So the K times 2 is 2K. Therefore, 2K and minus 1 times 3 minus 3 is equal to 15. So K over the 15 and get 18 and divide by 2. K equals 9. This gives you K equals 9. That is right. But 2 times 9 is 18. 18 minus 3 is 15. So K equals 9. When you work it out. K equals 9 is the answer. All right. So we set up what we call an quality of matrices to work it out. All right. Next part. Vectors. Question says the following vectors are defined as follows. So give us WX, W to X, X to Y, and then Z to Y. It said determine each of the following. Determine each of the following. A vector other than 5, -1 that is parallel to WX. You need a multiple of WX. Parallel vectors are such that one is a multiple of the next. So that vector will be equal to anything times 5, -1. Like 2 times 5, -1. It should be 10, -2. That's any value. It can be any constant times the vector. You can put any value right here. That's just an example. You could put a negative value there if you want. You could any constant value there you could put. So when vectors are parallel, one is a multiple of the next. All right? One is a multiple of the next. So basically any multiple right over here. So any multiple of 5, -1. Any multiple of 5, -1 is parallel to 5, -1. Example. This one, the example. All right, next one, the one, WY. So how do we go from W to Y? Okay, look at what we have now. We go from W to Y. Since X is connecting the Y and the W, can you use them? See that? The X is attached to the W. It's also attached to the Y. So we can go from W to Y by going through X. So see it here now. We go from W to Y. Let's go back for the blue. We can go W to X first and then go from the X to the Y. Like that. Simple as that. So it's the WX plus the WY, which is 5, -1, and then the -3 is 7. Let's work that out. The 5 and the -3 is 2. The -7 and the -1 and the 7 is 6. Same as 6 minus 1 is same as 7 minus 1 is 6. That's 2, 6. They walk from X to Z. What is connecting the X and the Z? So the Y is connecting the X and the Z, but just that they give us ZY instead of YZ. So we can turn this around and say from this vector, the YZ is negate these would be -8 7. If CY is 8, negative 7, when you spin the letters around, you reverse the order, you negate the vector. So, we go from X to Z, we can pass through Y. We can go X to Y first with this, and then go to Y to the Z with that. So that's what we're going to do. So we're going to go X to Y first. We're going to go X to Y first, and then go from Y to Z. All right? So the XY is the same, negative 3, 7, negative 3, 7. And the YZ is this, negative 8, 10. Negative 8, 10. Negative 8, not 10, negative 8, 7. Negative 8, 7. Which then works out to be negative 11, 14. That's the answer. So the answer. So. Want to go to that? Yeah? All right. Then I want the modulus of XY. What's it, XY again? XY is 5, negative 1, right? No. XY. XY is negative 3, 7. Negative 3, 7. So this modulus of XY, hey, where you going? I need to know what you get. Where you going? I need to know what you get. I need to know what you get. It becomes the square root of the 3 squared and the 7 squared. Remember that Pythagoras theorem, guys. So it's 3 squared plus 7 squared. I don't need to put a minus on it. But negative 3 squared is still a positive 3 squared. So it's 3 squared plus 7 squared. That's 9 plus 7, 7, 49. Square root of 58. I can't leave it like that. I don't have to work out of that decimal. Can't leave the square root of 58. Remember the vector, this vector. Hey, youngster, sit down, man. What's happening now, McLeod? You call the father, your sister, your mother, your brother, your uncle, everybody. And complain about you. So remember, guys, why this is the modulus? Because it's actually length. Because the vector xy right here, go from x to y, you have x right there. To go from x to y means you go 3 to the left. That's 3 units. And then you go 7 up. 7 up. So it will be 3 to the left, 7 up to take you up to y. So this is the vector that you want. That's the vector xy. And so you want to find this length. So to find that length, like Pythagoras theorem. And that's why I become the square root of 3 squared plus 7 squared. Obviously, it's 7. So that's why the length of that line. This means the length of the vector. That's what that means. The modulus means the length of the vector. Length of this line. So the square root of 3 squared plus 7 squared. That's how we get this expression. That's where it comes from. All right? Come on, let me know how much I get now. I want to know how many I got. Score. Huh? My pass mark is 65%. Huh? 80? I want you to pick your items, say 80 quick. All right. All right, good. 6 pass mark is 65%. We're doing another paper Thursday. We're doing another paper Wednesday and a paper Thursday. We're doing a paper Wednesday and we're doing a paper Thursday. And the pass mark is 65% still. Huh? Come on, come on, come on. When the time you get you can leave. All right, good. Once you get over the 65, I'm all right. Huh? Good. This paper ready. My people may talk, I'm not going to bother you. Oh, my people may talk about it. No, the one I'm no, talking about. You're going like a loose man in me. Happy brother 8 and 9 subject, I'm not an excuse. Come now, let me hear now, let me hear, let me hear, let me hear. 67, 67 again. Come here, youngster. You fit say I go. How many months you get yet? What's you get? Huh? Huh? You never do it? Why? Huh? You practice French? So I practice French all day, every day. Huh? All day, every day I practice French. You have no time for math at all. French alone you do? French alone you do? Boss man, you have to practice the paper them too. I'm not where you're there. I'm not gonna know your preparation I go. Come here, youngster, I'll go walk through the door. Hey, man, start at the door there now. Come here, man. Where you going? So me ask you 10 minutes going on at the moment. No, I'm here to tell you know to say it. You tell me. I want to hear. I want you again. Because your mother asks you, you must say your mother. You say your mother stand up on your neck, you know. You know that already. Your mother not ramping them. Students online, how much I got? Computer screen. So, Jado, how much I got? Shamik, how much I got? Williams, how much I got? Not anything. Everybody gone silent. Anyway, I'm ending the session now. Send me a WhatsApp how many you got. Everybody, send me a WhatsApp how many you got.